Hello and welcome to helpyourmath.com. In this video, we're going to look at writing algebraic models of linear equations. In the first example, a salesperson earns a base salary of $450 per month plus 5% of their total sales for the month. Find a linear formula for monthly income in terms of sales. So it looks like we have two variables here. It's defined in the second sentence, monthly income, which we'll use I to represent monthly income, in terms of, and then we have our independent variable, we'll use S for sales. We do want to be careful using S for sales. We want to make sure the S really looks like an S and not so much like a 5. So I'll do my best to keep it very, very curvy and my 5 to have a very rigid top. Okay, so how much is the monthly income? Well, what's going into the monthly income? It tells us in this first sentence, the base salary of $450 per month. So that's going to happen no matter what the salesperson does, plus 5% of their total sales for the month. So we're going to set this up. The monthly income will be that base salary, $450, plus 5% of the total sales. So that's 5%. And what are we calling the total sales? We're calling that S. So 5% of S. How do we represent 5% of S algebraically? Well, we can't use the percent, so we'll convert it to its equivalent decimal by dividing by 100. Dividing by 100 is going to move the decimal point 2 places to the left. So we get 0.05 times S. And so we'll say 0.05 times S. And that's it. This is the model that we would use for this particular situation. Now, we're not told anything, but maybe we're told this person made $10,000 in sales or $500 in sales. If we knew how much they made in sales, then we'd be able to calculate this particular salesperson's income. But we don't have that information. We're just setting up the model, and there it is. In our next example, it says a cable company charges a flat rate of $15 per month plus $5.99 for each on-demand movie ordered. Write a linear model that calculates a total monthly cost as a function of the number of movies on demand. Okay, so again, we have two variables here, a total monthly cost, so we'll use C for cost, as a function of, so the independent variable is going to be the number of movies on demand. So we can either use M or N. I'll use M for movie. And what do we know? Well, we know that the total cost is going to be a result of this $15 per month plus the $5.99 for each movie ordered. So what we're looking at is the monthly cost. So the monthly cost is going to be $15, even if we didn't watch a single movie, plus $5.99 for every single movie we watched in that particular month. This would be our model for this situation. In our last example, a school play charges $11 for adult tickets and $5 for children's tickets. The play earned $1,210 in ticket sales one night. Write a model using A to represent the number of adult tickets sold and C to represent the number of children's tickets sold. So in this case, we don't actually have an independent and dependent variable. They're both independent variables. We're using A for the adult tickets. So how much money would they make from the adult ticket sales? Well, that would be 11 times however many they sold. So we're going to say 11 times A. This is going to be the money earned from adult ticket sales. Okay, and then how about for the children's tickets sold? Well, those are $5 each, so we're going to say 5 times C is going to be the money earned from the children's tickets. Okay, and what else do we know? We know that the total sales earned was $1,210, so we're going to say the money made from the adult tickets plus the money made from the children's tickets is equal to the total amount, and that would be our setup for this particular equation. This has been a look at setting up linear models. Thank you for